Okay, so welcome to, what do we got, week 13. Okay, as always, okay, sorry, my database engine would like some attention. So there it is, now it's done with. Okay, won't bother me again. All right, so welcome to week number 13, also known in this case as lab exam week, which of course we've got coming up on Saturday morning. So again, I've said before, I apologize for having to drag you in, but it's the only way to get a fair exam for everybody. All right, so what we're going to do this week is I've set aside both classes to review some stuff for the lab exam. It's a little excessive. One class would have been fine, but in any case, that's fine. I don't mind doing this, except that probably what will happen is we'll probably be a little short this time, a little short next time, but it's fine. You got some stress coming, so maybe it's good that we have kind of an easy week then to get us through. All right, so unfortunately in the labs, however, it's kind of business as usual with a set of exercises in quiz number 4. Yeah, we've tried doing lab exams or lab exam reviews in the lab sections. It's not productive. Sorry, that's why we don't do it. All right, in any case, so the way I propose that I do this today is I didn't really come with specific things in mind to do. Well, not directly, so I kind of have an idea about what it is I'm about to try. I propose that I probably grab, say, the first 2 or 3 questions out of the lab exam from last semester, because those will be, those are the right level compared to, say, the ones that go back a long ways. But the most recent one from winter, I think they're kind of at the right level. The only issue is there's no dictionaries in it. Okay, but at least in terms of level of complexity, that'll certainly be here. And I will work my way through it kind of from beginning to end. It won't be just, here you go, here's a question, here's a solution. No, I'll walk you through the usual process that I follow. You know how this is. You know I'm going to write a function, I'm just going to print something, and then I'm going to start iterating through the data structure so I can see things. I'm going to get rid of the things I don't want to see. I'm going to calculate some stuff, and eventually I'm going to produce a return that I'm going to send back. It's a standard process. It's the same process I use all the time. It's the same process that I use even outside of this course. Okay, so I plan to do 3 of those, well, 2 at least, and then I'll see what time it is. And then for fun, what I'll do is, since I did provide you with an AI prompt, all right, I'll take my chances and I'll paste it in the ChatGPT and see what it gives me, and then I'll try working through it. I tried one of these earlier today. They're pretty challenging, some of the things that came up, but hey, it's a reasonable thing. And I think probably even just if we work together, we'll probably get through it. All right, so that's my plan for the day, is to just work through a couple of these examples. Now, unfortunately, I think what may have happened is sometimes copying and pasting stuff from this version of the PDF reader doesn't always copy and paste well, so I'm going to hope that this works. If it doesn't work, I'll have to go back to the Word document, and if that's the case, I'll make sure it's available. All right, but in case, here we go. So we've got questions. I went back as far as fall 2023. Okay, I'm not saying that they're not valid, but if you take a look, you'll see there's only one question. You say, wait a minute, so from fall 2023, there was 1 question, and now you expect me to do 5? No, you have to remember there was probably 2 extra questions in fall 2023, but because things were kind of delayed and we were covering material from 1101 and 1201, we ended up with some very simple functions like, okay, give me a function that takes a string and splits into 2 things. Things that are not appropriate, that will not get you through this course. Okay, so it made no sense to include these, because I don't want to say, oh, look how easy these are, and then suddenly show you with really tricky things. So I included what I thought were only the appropriate things. Like, for example, I've got a list of tuples. That's certainly fair game, and you'll see that. But I would say maybe what I should do is if I scroll forward to winter, winter 2025, is what I'm looking for. At this point here, things have more or less started to pop together into what I would call fairly standard formats. You'll notice that it's always the same thing. We don't ask users for inputs, where you simply say, give us a function that does something. Here's what the input looks like. Here's what some outputs might look like. Please keep this in mind, just like the assignment. There's sometimes, okay, I try to avoid misinformation on a test because you're stressed already. And what I mean by misinformation is results that are incorrect. Okay, I try not to do that. Sometimes it happens. sorry, I don't mean that. But generally the output is to say, okay, what am I looking for? Well, I'm looking for a list of strings. Okay, yeah, that's really what you should pick from this, not, oh, the answer must be battery cable sensor. Okay, in fact, this one's actually not bad in terms of how this is going. All right, so as I say, what I'm going to do is I'm going to pull through, we'll do the first 3 of them, I think, and then we'll see what time we've got. And then, okay, as I said, we'll dare and we'll see what ChatGPT gives me as a possible thing, and we'll try to work through it. All right, so question number 1, write a Python function called compare supplies. Okay, that's fine. That accepts 2 lists. Okay, remember, it's always the style. You're never going to ask the user inside your function, please enter this information. No, there will never be input. Okay, I can guarantee you there will not be input. That's not the type of thing that you're going to be measured on a lab exam in 1201. Lab exams in 1201 are measuring your ability to write functions that process data collections. Okay, that's the whole purpose. So what do I mean by a collection? I'm talking lists, sets, tuples, and dictionaries. That's a collection. Okay, and is it going to be like simple things like just a tuple with a bunch of integers? No. Maybe on the midterm we might give you a simple integer, but everything coming up, it's definitely going to be more complex. So this question right here is actually a little bit funny because it takes 2 simple lists. So this one might be a little bit easier than really kind of our target. All right, but in any case, we still do it, so there must be some challenges involved. Okay, so compare supplies, it takes 2 lists as a parameter and returns a list with only the items in common with no duplicates. All right, now, when you see the word no duplicates, that should immediately trigger in your mind, bing, 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 set. Right? Because sets are what's used to get rid of duplicates. Yeah. All right, perfect. Oh, but it doesn't say it returns a set, it says it returns a list. Yeah, but that's fine because if you have a set with a bunch of items in it, is it difficult to turn it into a list? And the answer is no. It's just list followed by the name of the set. So that's easy, very easy to turn it back in. Now, the other one, it says find only the things that are in common. Oh, okay, so again, if you think sets and you have a couple of sets, what's the stuff in the common? Well, it's calculated by using the mathematic computation called intersection. Okay, it's intersection. Union is everything without the duplicates. Okay, and that could be a slight modification to this. All right, so if we're looking for things that are in common with no duplicates, a set intersection is probably the right thing. And you'll notice the question doesn't say this. And no, it's never like use a set. No. This is a thinking problem. Okay, this is the problem solving where you have to say, okay, I need something in common. Okay, I've got this set thing which I can use an intersection. No duplicates. Yeah, definitely a set. Once you decide on this, well, now it's really just a matter of implementation. Okay, and hey, you grab a piece of paper and you start scribbling out some ideas if you have to. All right, so that's the design part. Okay, now the implementation part. Okay, compare supplies. Well, I suppose what I could do is I could grab, say, the code right here. Now, unfortunately, when I take the code out of a PDF document, paste it in, sometimes you get some really, really bizarre results. Like sometimes things that look like quotation marks are not really quotation marks. Okay, don't worry, on the lab exam, you'll be able to copy and paste it directly without any trouble. Okay, so here we go. We'll just give it a run. Okay, yeah, that kind of makes sense because it says compare supplies not defined. Well, that's the function you got to do. Now, what about all the other test cases? Well, you know what? My recommendation is get the first test case to work first. The test cases that I usually provide on any question, or anybody would provide, is we always start with kind of like the easy test case, the ones that are kind of more normal. Not the weird cases where there's nothing in common, not the weird cases where the inputs are empty, but just kind of the general purpose case. Okay? So start with that one. There's no reason to copy everything else. Okay, well, we need a function. It's called compare supplies. Okay, compare supplies. And of course, it takes 2 lists of supplies. Okay, do we call them list 1 and list 2? If you want to. Okay, entirely up to you. Whatever you call your parameters inside, the parameter names are entirely up to you. If you don't like if I've given you a function signature which contains the names of the parameters, feel free to change them if it makes more sense. List 1 and list 2 will work perfectly fine. If you want to call it L1 and L2, okay, yeah, I'd probably be okay with that too. All right, but list 1 and list 2, not because it has to be called list 1 and list 2, but I don't know what else to call it. All right, so, or maybe, okay, you know what? In that case, let's call it supplies 1 and supplies 2. At least that way we've got something different. All right, so here we go. And what do? Well, we start off by doing a simple little return none. Okay, at least I know that I've got something working. I know that the function is working. I don't have it misnamed. I've got the right number of parameters, et cetera, et cetera. Unfortunately, again, as I wander around through the exam, and I'm not saying this is going to happen because I'm trying to be more cognizant and say, hey, look, you got to watch out for these things. I have seen students in 1201 before sometimes get stuck. They will write 20 or 30 lines in a function, and then they start to run it for the first time, and they've done something absolutely stupid. Well, it's a typo, and they've accidentally passed in an extra comma, because it was beside the L key. And of course, they've got like 20 or 30 lines of code. They're looking at an error. They have no idea what to do. Okay? Don't put yourself into this situation. Have a single line program and you say, hey, how come this isn't working? Read the error message. Again, I've seen students stuck on messages like this because they actually don't understand what this means. It's missing one required positional argument. What does that mean? That means it's an argument that must be provided. It's something without a default, okay? And you say, well, hang on, how many do I have here? Oh, I'm expecting 3 of them, but I'm only passing in 2. Yeah, I've got a mistake, so find the mistake. Okay, because I can't help you with that during a test. Your invigilator can't help either. All right, so we got the supplies 1 and supplies 2. I suppose as a very, very simple thing, what we could do is we could start by just printing. I mean, this wouldn't be absolutely necessary, but sometimes it can sort of give you an idea that, yes, I am really getting the data, because sometimes people call them the wrong thing or they accidentally flip around the names. Just make sure you've got the data you're expecting. Is that really the first set of supplies? Yeah, it's a battery, cable, sensor. The second one is sensor switch, antenna, motor, sensor. Okay, excellent. Now, unfortunately, what these are lists at the moment. And if I wanted to do an intersection of these, because I'd want to find the things that are in common, okay, well, they would need to be in sets, because you cannot do an intersection with a list. Okay, so turn them into a set. Okay, how about set 1? Why not? Okay, supplies 1. And I'm just going to print set 1. Set 1. Okay, I'm going to do this one piece at a time. All right, so there we go. Is that a set? Well, no, that isn't a set. That's a list. It's the same list as before. Well, how do you take a list and turn it into a set? You have 2 options. You can go through and add a bunch of stuff if you would like. Okay, in fact, I'm going to solve this a second way as well, based exactly on this. So let me leave a note down here. Build a set 1 item at a time. This is a note from me, don't read this. All right, so how do you turn something into a set? 1, you can build it up by going through all of the items and adding the items one at a time. Probably an easier thing is, well, we've got this really nice little function called set. And it will take just about anything as a parameter. It'll take a list, it'll take a tuple, it'll take a dictionary even, and what it does, it turns it into a set. Oh, and it also gets sort of duplicates at the same time. All right, and you see when I run it this time, well, now I've got myself a set. And all the duplicates, if there was any, well, now they're gone. Ah, perfect, because you see, the battery used to be listed twice. Well, now it only shows up once. Okay, excellent, that was pretty simple. All right, hey, look at that, it even ended up in the same order. Well, that's really convenient, okay? All right, that's for set 1. Guess what else we're gonna do? We're gonna do the same thing for set 2. Now, do I really need all these variables? And the answer is no, I don't, but please bear with me. I like to break things out when I'm in the classroom. I don't like to take shortcuts at all, because I want everything here to be deliberate. It wasn't just, oh yeah, I remembered this weird thing. All right, so I've taken the supplies 2, I turned it into a set, and I'm also printing it again. We have a couple sensors. One of the sensors disappeared. That's really nice. And this is nicer because now the set is in a completely different order than the list. Okay, I was hoping it was going to happen. All right, so switch showed up first, even though it wasn't first. Sensor didn't end up at the end, even though it used to be on the end. All right, now that I have 2 sets, what can I do? Well, now you can calculate the intersection between them. All right, well, at this point here, it now breaks down to a couple of things. So remember, there's a few things I said, sorry, you have to kind of memorize this. Okay, let's have a result. Let's take the 2 sets. Set 1 plus set 2. And you know what? Let's print the result. Okay, so this will be the third thing. All right, like that? Oh, no, you can't do a plus with a set and a set. Yeah, that's not how you put things together. That's one. So we very quickly determined this, but there are 3 operators that you can use. And what are they? Okay, and. So do you mean and like this? No. I know what you're talking about. That's not an and. You're talking about this symbol right here. Hey, you got to know this. This is officially called an ampersand. Okay, that's the name. Okay, so because you might run across this sometime where somebody says, well, use an ampersand, and you'll say, well, I don't know what that means. Well, now you need to know. All right, the ampersand, okay, but we know it means and. Okay, so what do we got? M&S, Marks and Spencer, right? Because they use the ampersand as well in their abbreviation. The word and kind of suggests things that are in common. So things that are inside this and inside the other one. That's exactly what we're looking for. Okay, that's exactly the end that we're looking for. Not that I need it, but what's the other ones? So there's 2 more. So I'm doing this as a review.
Or.
Okay, or? No, not this. All right, this is not called or in this language. Okay, that is a vertical bar, or sometimes they call it a pipe, because it comes from the world of Unix, where you're taking something, passing it through something else. And in other programming languages, that symbol usually goes with the second one to say, okay, this is going to be the magic or symbol. This is what we use in JavaScript and Java and C and C++. But this one right here basically means or. Okay, you don't pronounce it as or, you pronounce it as pipe or vertical bar. You'll be fine with this. And what it is, you're basically saying, okay, tell me what's in set 1 or set 2. Okay, also known as the union. All right, if I run this one, I get all of the items, not the items that are in common, but I get all of them. So if you can't remember, oh, was it the vertical bar, was it the ampersand, try them, print them, see what you get. I mean, you have an interpreter. I mean, that's one advantage of having an interpreter over trying to guess. We also have this one right here. Okay, that one's pretty simple. This is the subtraction. So it would give me all the things that are in set 1, but you take away all the items that are in set 2. And there's one final one, which is also kind of weird. That. Okay, so what would you call this? Okay, what do you want to call it? It's fine. I think I heard it. No. Some people call it a hat. Okay, it's fine. Yeah, it's the French, it looks like the French symbol that shows up on a few vowels. The official name is called a carrot. Not a carrot, like a Bugs Bunny carrot, but it's called a carrot, C-A-R-E-T. Okay, so it's a positional thing. Anyways, what this is, this gives you something called the, what do they call it? The symmetric difference. It's the things that are not in common. Okay, so basically it's the opposite of the intersection. All right, of course, what we're looking for is this one right here. We're looking for the things that are in common. Very good, we've got this. But the issue is that if I return the result right now, no result in it? Okay, if I return the result right now, the result, and I clean up all of this other stuff, and you say, yeah, I've got it. Well, not quite, because it's in a set, and it's supposed to be in a list. All right, so here's what I'm going to do is let me introduce another variable, and I'm going to call it a result list. And how do you take a set and turn it into a list? You use the list function. All right, you put in your result here, and you return the result list. Wow, do I really need all of those variables? And the answer is no. A lot of people would probably do this in a single line where they would say return list, and inside the parentheses, set supplies 1, ampersand set supplies 2, done. It would be one line. Yeah, I mean, I'd have to give you the marks for it, but in terms of me explaining it, that's magic. This is not magic, this is procedural. We checked everything as we went. All right, now, the only thing here that we have to watch out for, oh, did we get the right answer? Yeah, we got the right answer, switch and sensor. All right, not this one, but let's get over to here. Sorry, here's my stuff. Let's grab this combo right here. I just want to try something, okay? Unfortunately, I don't know if I'm going to be able to make the problem that I want appear. Okay, let's check this one. Battery cable sensor. Oh, you go away. Uh-oh. It must be a mistake, right? I saw a student on this for 45 minutes. Had a complete working solution and basically erased it and tried a dozen other ways to try and make the output look exactly the same. Was it even possible? And the answer is no. It's not possible. Okay, yeah. Whenever you're dealing with sets and dictionaries, the order is not an important thing. All right, now, did I say anything? Oh, look at that. Please note the resulting list could be in a different order than what's shown in the sample output. Yeah, I usually try to remember to stick this in because the idea was to actually create was to use a set. So usually I will try to remember this. If you get stuck into a situation, feel free to ask your lab instructor, whatever theirs is like, is this supposed to match exactly? But if you use the set to solve your problem and you're getting the correct output, you're fine. And is that the correct output? And the answer is, yeah, because what's the function supposed to do? It's supposed to return the items that are in common. It doesn't say return it exactly in the order shown. The only way I could show something in the exact order shown is if I said, okay, you have to sort it. Okay, but it didn't say sort, so you don't have to sort it. Okay, so just keep this in mind. Different times you run it, you might get different results. Okay, am I finished? Submit it? No. We have a couple of extra things. We really do have a couple of extra things. Here we go. First one up, doc strings. Okay, this seems to be the most common question I'm getting these days is, do we have to put a doc string? Yes, you do. It's part of the coding guidelines for the course. Okay, I mean, you could watch me type it and I could write one out if you really want. Yes, copying and pasting the instructions, it works. I prefer the people who actually write their own. Okay, and I don't mean you have to write an entire paragraph. Just write a quick little description. It means that you put some effort in. Don't worry, if you copy and paste, I'll still give you the marks. Or sorry, oops. If you include it, you don't get marks. If you don't include it, you get a penalty. Okay, that's the way how doc strings work. So no, nobody's getting marks because I put a doc string. No, sorry, it doesn't work this way. If you don't put it because you're violating code guidelines, you lose something. Make sure your function has a doc string. It doesn't take very much, and it will save you some marks. Okay, just do it as a quick check at the very end. As soon as you get in, you got a piece of paper and say, don't forget the doc string. And before you submit, just go through each of them and make sure it's there. Okay, all right, copy and paste this, submit, move on to the next question. Okay, let's take a look and see what I've got next. I hope I've got something a little bit more interesting next time. Okay, ooh, okay, that's not bad. Okay, that one I like. All right, this one says some sporting events some sporting event points have been collected into a list using the following format. All right, I see Ahmed 100, Fatima 85, Muhammad 95, Aisha 70, Yusuf 90. The list contains an even number of elements. The even positions of the list include the name of the player. The odd positions contain the points for that player. All right, so the way how this reads is that Ahmed has 100 points, Fatima has 85 points, Muhammad has 95, Aisha has 70, Yusuf has 90. All right, why would somebody put data like this? Because you're in the middle of a infs1201 test. That's why it's here. Do people actually store data like this? Not very often. It doesn't mean that couldn't happen, though. I've occasionally run across this type of data. It's called interleaved data because what you've done is you've taken some piece of information, which is the name, some pieces of information, which happens to be some scores, and we've literally done this to it. Okay, sometimes it happens, and one of your jobs is, if you want to process these things, you want to break it apart. Okay, it's the first thing that I would do is if I had two pieces of information that were somehow merged together and they were completely different types of information that really should have been in two lists, the first thing you do is you pull it apart. Once you pull it apart, okay, oh, we haven't even read what this is. We're supposed to write a function called best players, which accepts the list of data along with a minimum number of points, which would be used as a filter. Okay, so we then come down, we take a look at the output. Okay, so we gave all of these and we said, okay, give me the best players with 90 or above. Okay, and it says it's inclusive. Okay, so you don't have to ask, does it include the number or not? It does because of the example. What we will do is we'd go through and we'd include Ahmed, we would include Mohammed, we would include Yusuf, because those are the people with more than 90 or more. Okay? All right, so now, how do we deal with this? Again, there's a couple of different ways how to deal with this. Before I do, however, I just suddenly remembered this one. Let me do this before I switch. I won't solve the entire problem, but just let me do a return, okay, because I said I would do this. Ooh, invalid syntax because I accidentally hit an extra button. There you go. There's another way to make a set. Yeah, you iterate through. I don't know, do you want to do that one or you just want to use set and pass in a list? Probably the way that I did it before. But if you did this, don't worry, I would take it. It's just one extra piece of work. All right, let's get rid of this and actually move on to the real problem. Okay, the real problem was, okay, we're going to take a bunch of this data and we're going to try to extract just the players with the high points. Okay. All right, so unfortunately, it's kind of gone off the edge. I'm just going to press enter here a couple of times just so I can fit everything onto a single screen. There we go. All right, so it doesn't change my problem at all. Okay, it just so I can see it a bit better. All right, so how do we find the best players? Okay, well, you need to come up with a mechanism. As I say, when you start to get this interleaved data, probably the easiest way is to extract it, because in the world of Python, we have this really, really useful feature called slicing. And slicing works really well for interleaved data because in a single line, you can literally split these items up into two pieces. All right, let's get started on this. What's the first thing I'm gonna do? Well, you know what's the first thing I'm gonna do. I'm gonna write a function, best players. All right, what's going to take us as some parameters? Well, probably like the player data, and it's also going to have some kind of a cutoff. Okay, yeah, it's the minimum points. Okay, here we go, min points. That works well. Min points. Here we go, and I'm just going to return none, just like what I've done before, or if you want, you can type blah or something, just so that we know we've got this thing working. All right, so here we go. We've got ourselves a function best player. All right, we've got a bunch of data. All right, well, in theory, we've got a bunch of data. You know what? I'm really paranoid. Print the player data. Is that really the data that I'm looking for? Yeah, that's the data I'm looking for. All right, but the problem is the data is now jammed together in this interleaf format, and I want to tear this apart. Now, the question has one slight misleading comment in it. It's legit, and it wasn't put here to try and mislead people, but I realized after watching the programs, or after watching the students try to solve the problem, they kind of fell into something because they saw the word, the even positions, and the odd positions. Immediately that triggered some people to go, oh, I know, even numbers are when I take a number, divide it by 2, and the remainder is equal to 0. And that's right, you could do this. Okay, you could do this. In fact, I will do that afterwards. That'll be my second thing. So let me leave a note here to myself that I might look at this time. A split without slicing. Okay, that's for me afterwards. All right. Whenever I have two pieces of data that have been interleaved together, well, we have to think about the list slicing concepts. So remember, we have two pieces of information. We have a bunch of names, and we have a bunch of points. Okay, so what I want to do is I want to be able to extract all this stuff. Well, one of the easiest ways to do this is if you take your player data, well, remember our slicing concepts. Okay, if I said :3, we have to remind you a bunch of things. Let's say 3 : and all I'm going to do is I'm going to print names. All right, my question becomes, what am I going to see? What does 3 : mean? It's a slicing operation. It starts from position 3, and how far does it go? To the very end. All right, excellent, there you go. So 85. It doesn't start at the third student. it starts at the third piece of information because, well, it's a mixture of things. All right, so that's an important thing. All right, second review. If I said :3. Okay, yeah, so wait, I got a question. Can you use an I+1? Yes, we could. I will promise I will do that afterwards, okay? That's my comment, splitting without slicing, okay? All right, so back to this one. The :3 will give me, where does it start? Starts at the very beginning, position 0, and how far does it go? Until 2. It doesn't include 3 because that's like the end limit. So yeah, this is going to be the Othman 100 Fatma, but it won't include the 85 because that's position number 3. And of course, you can also put these things together and you can say, give me between 1 and 3, which says start at 1, but go up to, but don't actually include 3. Okay, all right, so that's the first thing. All right, hopefully you remember that there's also a third parameter that you can stick in, and it's called the step size. Okay, this is very, very handy for interleave data like this, because a step size of 2 says, well, step 2 each time. And if you think about these names, the names have exactly one thing between each of them. And the scores have exactly one thing between each of them. And that's a very useful property. So by asking for 2, that means start at the beginning, go to the end, step by 2. So that's going to give me position 0, then position 2, then position 4, then position 6. And that happens to be exactly the names. So if I run this one, there we go. Now I've got a list full of names. That's pretty nice. All right, and how do we pick out the points? Okay, well, here we go. Let's print out points. How do you pick up the points? Well, the points have exactly the same concept. It just happens to be, instead of starting at 0, they start at 1. 1, : 2. Print points. Ooh, I forgot the name of the list. Sorry, I thought I typed that. Here we go. There we go. So now I've got the names and I've got their points. Excellent. I've now managed to separate these two things into 2 lists. That should be a little bit easier. I mean, if I wanted to, I could now build up tuples of these things, although I don't think I need it for this. All right, at this point here, let's start printing everything. Let's print the name of the person and their score. Now, printing the names of the people, that's pretty easy. It's a for loop. Okay, printing the points, that's easy. It's a for loop. But the problem is that if you have 2 lists and you're trying to traverse these things at the same time, because position 0, they're supposed to match. Like, for example, how many points does Fatma have? Why? Why does Fatma have 85 and not 95? Because Fatma is at position number 1, and therefore Fatma's points is also at position number 1. It's the same location. It's the same index. Whenever you're trying to traverse 2 lists in parallel, is what I would call, it's called parallel iteration, I would almost always use one of these things for index in range length of something. Ooh, length of what? Well, how about the length of the names? We'll deal with all the weird cases in a few seconds. You see, if I go to names at index, and I also print points at index, see what I've got? I've got exactly the names of the players along with the number of points that they've got. I've got some other stuff being printed as well, but okay, maybe we'll clean this up now so we don't get confused. All right, so we'll get rid of this one, we'll get rid of this one, we'll get rid of this one, and I'll just drop out the blank lines. Okay, here we go. All right, now that's not everybody, or sorry, that is everybody, but it's not who I want to see. I only want to see people who have a certain number of points. Okay, so how do you sometimes show something and sometimes nothing? It's an if statement. I would have to ask the question, if the points at the index is bigger than or equal to the minimum number of points, okay, print that. There we go, there's the 3 people I'm looking for. Now, of course, this prints it. Oh, and by the way, you do something like this and you print this, that's better than having a pile of syntax errors. You're not going to get full marks, but that's going to give you a lot more marks. Okay, for this, your logic is going to be almost full, and in fact, your execution is probably also going to be at least something. Okay, it's better than some things. All right, but of course, yeah, we don't print things in this course inside functions unless the function is called display something. Sometimes it happens, usually not, but sometimes it does happen. So if you want to send back that as a list, which is what we're looking for, is a list of names, okay, well, let's have a place to put them. Same approach that we've done before. We have some kind of a variable that contains an empty list, and whenever I find something of interest, I just keep tacking it on with an append. When you're finished, you can return it. So we're talking about result.append, and we're not interested in the points, we're just interested in the names, and at the end, return result. If you can print it, you can return it. Okay, this will actually become important as we get some really difficult or some really tricky things. Now, there's going to be a bunch of extra conditions in here that we have to watch out for. Okay, and we have to make some decisions about how we're going to deal with it. Are we doing okay? Yeah, we're about on time. Okay, so the function returns, okay, if the list contains an odd number of items or nothing, then the function must return an empty list. Ugh. Okay. There, you go away. Let me turn on the hide so I don't come back. Okay, so for example, you can see this one right here. We passed in an empty list and the whole thing blew up. Well, if I go and I actually pass in, say, an empty list, is this going to be an issue? Okay, well, that works. But you have to watch out for it. You have to check to make sure it's okay. But in this case, my solution worked. Maybe the split without a slicing will not work. I don't know yet. We'll have to come back to that. All right, but then we have this other real problem, which is what happens if I do this? Okay, so what did I just do? Okay, in case you didn't watch, I'm getting rid of the score for Yusuf. Let me go back and let me ask for data once again. Okay, because this is a real problem. The issue arises because, well, Yusuf doesn't have a score. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. It has an odd number of items. When you try to run it, it blows up and it goes bah. Okay, yeah, that's an issue. Okay, that is a legit issue. So in other words, I can't have this situation. I don't want this to ever blow up. Okay, because it actually said, what am I supposed to do in this case? Return an empty list. Okay, in that case, right at the beginning, before you start anything, if the length of the player's data, how do you figure out if you've got an even or odd number of items? Divide by 2 and see if it's equal to 1. That will tell you whether or not there's an odd number. And in that case, it's an empty list. Before you do anything else. You don't have to worry about modifying it. It's a one-off condition. It's a weird case, and you just put it in this way. You have to watch out because sometimes the question may show up and it says, if there's an odd number of information, then get rid of the last item. I could do that. And what I would do is I'd probably want to modify something in here. It's a little bit more challenging. Then you might want to just get rid of it, but I would use list slicing to chop off the very last item and then proceed with everything else. Okay, that could be something. Now, I won't solve the entire thing again, but I will go back and I think I will hit the question that was asked earlier is, well, can I just use like an I+1? Okay, yeah, let's do something like this. Okay, so let's go at this approach where we had we fell in, I hate to call it fell into the trap, but we got the idea that, okay, names are at even positions, scores are at odd positions. Okay, it's a reasonable thing, except we're going to have a real trouble with this. Okay, and there's many different ways of dealing with this. For example, for index in range, length, player, data. Print index. Okay, that's not very exciting. Oh, and I better put back another score for Yusuf, so here he goes, 30 again. All right, so those are the index positions, and this is what I was seeing. Okay, I was seeing something like this. Students would have, if index modulo 2 is exactly equal to 0, what do I have? What do I have? I have a name, right? That's what I've got. So I'm just going to say name, comma, and I'm going to say player data at index. Okay. Otherwise, what do I have? with scores. Player data index. Okay, there you go. So, good, we've got it. Does that help me solve my problem? Well, at least we've identified it. Okay, we've identified it. So we could do this, except for me to be able to do any types of calculation, I really need these things completely separate. Because the issue is that when I'm in index position 0, I know the name, and when I reach position 1, I've forgotten the name and now I know the score. Oh, so in other words, I'm kind of missing something. There are things that we can do, okay? Just to give you an idea about what I could do. All right. So I'm only going to look at this whenever it happens to be this. Oh, I'm going to print out the player's index. Okay, so if I run it right now, what am I going to see? Not a trick question. Just the names. Okay, good. Just the names. Okay, get ready for this one. Player data index +1. And I believe that this may have been related to the question that was asked earlier. Okay, when I look at player data at index +1, what does it give me? Well, it gives me the very next item. Oh, so not only am I going to see the player's name, I'm going to see the scores coming right afterwards. So if you like this one, that's completely fine. Oh, could we do something with this? Sure, sure. Let's solve the same problem as we just had. So I'm going to ask if player data at index +1, if that's bigger than the minimum number of points. Okay, here's what I'm going to do is I'm going to print the name. There you go. There's sorry, now there's only 2 names because I got rid of, I changed somebody's score down here. So here, we'll put it back, 98. There you go. There's the 3 people. Okay. Hey, it's a different way. Do you like this one? Entirely up to you. I like basically ripping the two lists apart, because then I've got lists which contain exactly the same thing, and I don't have to look at this one plus the one ahead of me. Okay. Oh, do I need the if index is equal, or mod 2 is equal to 0? And the answer is no. But you see, if I get rid of it, all right, I have to put it in here. There we go. If I tried this, the whole thing is going to blow up, because now I'm dealing with strings and ints, because I'm going through position 0, then position 1, and I take somebody's score as the name, and then the next name as the score. But what I could do is I could go through a range. Well, remember, ooh, not this one. Well, remember what we've got to do. We could say go from 0 to the length, stepping by 2. Oh, that's basically what I just did a few minutes ago. All of these are possible. I prefer taking the 2 things because I get variables that make sense. I know what these are. These are names, these are scores. I find it's just easier rather than this. But hey, if you produce a solution that looks like this, I'd go, ugh, and I'd have to give marks for it. Okay, all right, how are we doing? Not bad. Okay, this is going to take about the right amount of time. All right, so let's do one more, and then we'll try one of the LLM generated questions. I'm actually quite scared of this. All right, but in any case, here we go. You get a bunch of sales data. Okay, sales items are tuples consisting of a location, and the second item is a total for a day. Okay, so some sales information. Doha Mall, there was 1,200 QRs sold. Al Wakra Market, 1,500. Doha Mall. Oh, so I can see that there's multiple things. Okay, so I wonder what they're going to ask for. All right, and it says right here, write a function called analyze sales that takes the following items parameters. It's the sales data, which is that list of tuples, where each tuple contains the string in the sales. This is what makes the problems really big to explain, is because you have to explain what's in the data. In fact, I think you probably noticed that in the assignment, the questions are bigger than the actual solution. But you need all of this context so you know exactly what you've got. All right, the function returns a tuple with 3 items. It returns the minimum amount of sales for the location. The second item is the maximum amount of sales for the location, and the third item is the total amount of sales for the location. Okay, oh, perfect. So this is returning a tuple. Okay, that's all right. And of course, if no information is found, then we're supposed to return a tuple with 3 zeros. Okay, that's fine. Well, let's start off and do the general test case. Okay, come on, we take this here. There we go. One more copy and... Okay, there we go. That's the information we're going to look at, and let's start as usual. Analyze sales data. Okay, I'll reuse data, and for right now, I'll just return none. This is, oh, see, I've got some extra things. I'm also supposed to pass in a location. There we go. All right, so we got both things put in place. All right, now what do we need to do? Well, let's just start by printing things. You see, if I've got a list of tuples, I'm interested in only some of them. I'm only interested, for example, in Doha Mall. So in other words, I wouldn't be interested in seeing this one or the last one. I'm only interested in these ones right here. So you know what? Let's start by just printing them. All right, so here we go. Oh, and I don't mean just a print. I mean iterate through, because you know you have to break it down into the individual things so that we can solve this problem. Okay, so for x in data print x. Oh, okay, well, I mean, that is all the information, but I don't like the variable x, but okay. Sometimes we don't know what else to call it till we see it. What would we call that? I guess I'd call it like sales or shop or results or what was it? I think it was called daily sales. Okay, well, whatever it happens to be. We're going to have to call it some kind of a name. So maybe what we do is we call it sales? Sale? Yeah, okay. Sometimes coming up with a name is really, really tough. But here you go. Here's a bunch of sale information. Sale information consists of, each one of these consists of two things. It consists of the name of the location and the second item. The sale, okay, maybe, okay, I've already used sale, maybe a different word. Amount. Okay, and this of course is for each one. So location. Oh, but unfortunately, I've already got a variable called location. Okay, let's call it shop and amount. Okay, yeah. And this is actually the worst part, is coming up with names. Okay, shops. The shop name is going to be something. The amount's going to be something. Okay, how do I get the something? Well, the good news for this is, here you go. This is each of the sales. That is a tuple. The good news is that the name of the shop always shows up in the first position. Okay, and if it didn't, well, that becomes a really difficult problem, not something that we would do here. But here we go, sale at position 0. Amount we'll always find in position 1. All right, at this point right now, print shop, print amount. I better see everything. Good, and I don't see the parentheses, which means they're no longer tuples, they are primitive variable types, which are easy because you can do comparisons and so on. All right, so I've got it down to single things. Do I really need the variable called shop and amount? No. Do I think it's a good idea? Yes. Because it'll make the next pieces of code a whole lot easier to write. And I would do this personally, yeah. Sorry, you want to see only the price? Okay, well, in that case, print just the amount. Okay, I would still pull out the shop and the name, and then, of course, just not print what I don't need. Okay. All right, so that looks after both. I don't want to see all of these items. I only want to see the ones that match the location. Okay, I think you have a good idea now how we're going to do it. Your turn. If state, okay. We don't say if statement, but we say if. Okay, so if location is equal to, you want me to reverse that equal and that equal? Okay. You want me to, okay. Is it what you're asking? The location in data, okay. In data, what? No. Location will never be found in data. Okay, why? This is actually important. Okay, what's in data? Data is a list, and it's a list of tuples. Will you ever find a string in a tuple? And the answer is you will never find a string in a tuple. You will find a bunch of tuples in a tuple, but you'll never find a string in a tuple. sorry, unfortunately, we have to look just at the first item. But the good news is we have the location already in a variable. The variable name is called shop. That's what we're looking for. Not a shoot, but a shop. All right, there we go. Now we've got it. Okay, this is what we're looking for, and we'll only print here. Okay, am I printing only the information I want? Yeah. Well, okay, I don't need the name, but I have the numbers. I have the numbers I'm looking for. I left the name in just to make sure everything is okay. Okay, but now, of course, I don't really care about this. But the issue is I need to do a bunch of, now I need to do a bunch of things. Okay, there you go. So there's the numbers. Okay, what is it that I need to do? Okay, if you remember, I need to find, I can't even remember what it is. I think of two of them, but I can't think of all three. Here we go. There's reader. We are supposed to return a tuple with the smallest number of sales, the biggest number of sales, and the total amount of sales. All right, go back to here. All right, what's the smallest? 1,100. What's the biggest? 1,600. And what's the total? Yeah, 3,900. You can grab a calculator and make sure you got the right number. Oh, and of course this matches the numbers that are down there. Okay, that's good. Now, is there a nice, easy way that I can find the smallest number? Okay, what's the easiest way to find the smallest number? You use min. But to use min, it means that you need to put all of these numbers into a list. I mean, you can put them into a set, but it'll be really dangerous, okay? Because if you put them into a set, it will blow up when you try to add them up if they happen to match. But yeah, or I guess you could stick them in a tuple. Well, but tuples it kind of doesn't make any sense. But if you take these sales numbers and put them into a list by themselves, you've got the min function. Oh, and you've also got the max function, and you got the total. Oh, that's really cool. You could also just go through and you could use the techniques you learned in infs1101 to find the biggest, find the smallest, and the sum. Set a total, adding the total each time, that works. But if they're in a list, that's perfect. But they're not in a list. Put them in a list then. It's your program. Do whatever you want. All right, so here's what I'm going to do is, for each one of these, I'm going to have a bunch of sales amount. Sometimes you have to be really creative with these. These will be the sales amounts. Sale amounts? Sale amounts. I think I might like that better. All right, here's what I'm going to do. Instead of printing it, sale amounts, append. Print sale amounts. There you go. Now, this is really cool because, well, now it's in a list. Now I've got access to all these things because I can find the min sales. Here we go. Here we go. Min sales. How do I find the min sales? Just min of sale amounts. Okay. How do I find the max sales? No, that's pretty tough. Okay, sale amounts. And how do you find the total sales? Well, at least it's not total, right? All right, it's sum of sale amounts. All right, print min sales, max sales, total sales, bang. Yeah, there you go. Those are the three items. Okay. Oh, but of course I'm not supposed to print them. I'm supposed to return them. Okay. Return them as a tuple. Oh, I've got an extra output. That's because I'm still printing for my debugging purpose. So away it goes. Okay, one doc string, you're done. Oh, but now we've got something is, okay, here we go. We have to try this one, Mall of Qatar. Okay, right, it's going to return zeros, right? Ooh, what happened? All right, unfortunately, it says in line number 9 of sales, we had an issue because if I were to print sale amounts. See what sale amount is? It's an empty list. You cannot call min on an empty list. You can't call max. Can you call sum? I think you might get a 0. All right, but in any case, but for the min, it doesn't make any sense. So we have to go back and you have to take a look. And remember, it said that if there was nothing, then return 3 zeros and you're done. Okay, so how do you figure out if there's nothing? Okay, there's a couple of different ways. Sometimes people will do this. They'll say if sale amounts is equal to an empty list, then we simply return the 3 zeros. Sales amounts. Oh, sorry, sales amounts. Sale amounts, yeah, sale, there we go. That's what I was looking for. All right, so that's one way. I'll be honest, I don't like comparing against an empty list. You don't lose any marks for it, but if you take this approach and you try to go off to another programming language, you'll probably find it doesn't work. Okay, so just keep this in mind. I prefer this approach where you ask and find out whether or not the length happens to be equal to 0. That's a lot more portable. Okay, it's a lot more portable because other languages have similar constructs. Okay, so this I prefer compared to comparing it against an empty list. Don't worry, you wouldn't lose any marks for doing it, but this one's a bit better. Okay, tack in a doc string and you're good to go. Whew, okay, well, that burned more time than I expected. Okay, but you know what, just for fun, let's try something. Okay, so that's the first 3, and what I will do is I will grab the deferred exam next time. We'll start in question number 3, and we'll do 3, 4, and 5, because those are supposed to be the slightly more challenging ones. Okay, so that'll be my Wednesday stuff. But before we go, let's take a look and see what we get, because I tried this earlier today, and I said, wow, that was quite impressive what it gave me. All right, and that is, the issue that I have is that the previous versions of the course didn't include any dictionaries, so I said, okay, here's what I'm going to do. I'll give you guys a prompt that you can copy in the ChatGPT. And the problem is that you can't just go to ChatGPT. I think you guys have probably bumped into this already. If you say, give me some Python programs, it will give you all kinds of ridiculous things, and a lot of them are super, super trivial. And if you practice on really, really simple things and you come into a lab exam and suddenly you see something that's considerably more complex, you'll suddenly realize maybe you weren't quite prepared. So the idea behind the prompt was, okay, try to make it so it's at least really quite interesting, quite difficult. So generally what I see out of this is more challenging questions, and that's what you want for practice, because you want to practice on the really hard things so that when you get to the lab exercise, you go, oh yeah, that's a joke compared to the stuff I was doing. Okay, so even if you get completely overwhelmed with these, well, give it a shot anyway. Now, I am going to open up an incognito window. The reason why I use incognito for this, and the reason why I asked you to do this for the assignment, wasn't to try and punish people or to learn about incognito, but the idea was, you see, when you open up an incognito window, it doesn't see your context in the other chats. Like, for example, if I go to my regular chat right now and type in this, it will come back with a snarky comment. Why? Because I trained it to do this. Because I said, okay, for all my chats, always do this. It just kind of makes it fun whenever I put something in. But it also knows a lot about this type of stuff we teach in the course, and that would end up causing this result to be highly skewed, and I don't want to do that. Okay, that's the only reason I'm opening this up here. All right, so we go off and you say, okay, you're an expert Python tutor. Okay, now, honestly, I told the other instructors, I said, okay, you can work through some codes if you want. If you're feeling really daring, do this and do it live. Because do we have any idea what's down here? I have no idea what's about to happen. Okay, so in other words, this is like putting me on the spot. Okay, so we'll see if we can solve the problem. All right, let's see how crazy of a question it came up with. All right. Okay. Okay, aggregating scores from a nested dictionary of lists. Okay, let's take a look and see what we've got here. Okay, so yeah, that's a dictionary, and inside the dictionary, I've got a list, and inside the list, I've got a bunch of tuples. Okay, that's pretty complex. All right, and what it's supposed to do is supposed to come back with expected output of the number of subjects and the total. I mean, I don't know why you'd calculate the total of points, but like, okay, fine. It's easier than an average, I guess. Okay, so it's a number of subjects. So let's see, Alice 2, I don't know what the -1 means. We'll have to look at it. Bob, 2 subjects, 90 plus 85, that's 175. That makes sense. Kara, 3 subjects, a total of 200. Let's see, 75 and 65 and 60. It's 100 and 25 plus, yeah. Okay, so that's the numbers we're getting. Without even going and reading all of the words, sometimes you can kind of infer things by looking at it. That is actually not a bad strategy. I didn't even look at the problem. I just looked at the output and said, okay, what do I think they're getting? Okay, I have no idea what the -1 means. Okay, because, I mean, are we supposed to subtract that? I don't think so, because 80 plus 70. So maybe it means it's a course that they dropped. I don't know. Let's go up and take a look. All right, so now we go back. So it says write a function called summarize scores that takes a dictionary with each key is a student name and each value is a list of tuples with a subject and a scorer. Your function must traverse the nested structure. Ooh, that's a word that I would never use. I wouldn't use the word traverse. Why? Because I'm leading you, telling you how to solve the problem, and I don't do that. Okay, just letting you know, if I took this problem and said, okay, I'm going to turn it, I wouldn't say that. I would say that you need to compute the total score for each student. That's all I would say. How you do it's entirely up to you. All right, build and return a new dictionary where each key is a student name and each value is another dictionary containing a number of subjects, total score. Here we go, and ignore any tuple where the score is negative. So that -1, we're supposed to just completely ignore it. Maybe it means that the student dropped. And normally I would say that just to put it into a context. So we've got a full thing. All right. Unfortunately, this isn't as difficult as the one that I got earlier today. But okay, that's fine. We'll work through it. And I will show you, again, the process. It's the same process that I always use. All right. So let's grab this piece of code. That's supposed to be the output. We'll get back to that later. Maybe I can put it here. Okay, I'll put it over here and I'll bring it back and forth as I need it. All right, let's see how we go. Okay, clear everything. Bang. All right, we've got a bunch of data. Okay, I think we can see, yeah, okay, we can see everything. That's okay, that's the comma. I thought there was more coming afterwards, that'll be fine. All right, we were asked to write a function called summarize scores. And we're supposed to pass in the student data. Okay, this must be the student data here. Okay, I would prepare this for you, but because it's ChatGPT, we have to do a little bit more work, and of course I'm going to print it. Okay, so here we go, printing, and I'm going to need a function, def function. I'll just call it data, and I'm going to return none. First thing I do is I run it, and you go, okay, student data. Okay, good. We got the skeleton set up. All right, so now we need to figure out what it is we're looking for. Okay, back over to here. Okay, well, you know what? Let's break it up into two different pieces. Let's figure out how to get the number of subjects separate from the total. Okay, yeah, we've got to see all of these things before we can start packaging things together. Wow, I should have really hung on to the question I did earlier. It was kind of more interesting. But again, we can try this on Wednesday. Maybe I get something a little bit more challenging because it really took like 3 parts. This one, naturally, I wouldn't solve it in 3 parts. I'd solve it in 1. But in any case, we'll just go for it. Okay, now I've got to go through each of the items in the dictionary because I have to go and I have to deal with Alice, then I have to deal with Bob, I have to deal with Kara. That's called iteration. Okay, because for each of these I have to do something. Okay, how do you iterate through dictionaries? Well, for loops is the easiest way. Okay, that's one of the options. Okay, oh, but remember, what this gives me is just the names of the keys. In this case, the keys are the students. Okay, but I need something more than just the keys. I also need the data. So hopefully you remember that we do have a couple of extra items in here. One is called values. The values will give you, sorry, finger slipped, there you go. That will give you just the values, but I don't need just the values. I need the keys and the values. One of the most common things that you end up using is items. All right, and this produces, everything is a tuple. Okay, now the tuples, of course, I don't want to call it X. Okay, the tuple, of course, I would normally save it into 2 variables, not called A and B. We'll give the name for a second, where the first one is the key, the second one is the value. The key is known as name. All right, and what's the second one? Courses. That's like the results. Okay, let's call it results. because that's what it is. It's a bunch of score results. And yeah, I'm going to print the name, I'm going to print the results just to make sure I can see it. Because if you can't see this and we are looking at the wrong information, then there's no reason to continue on and make a mess out of other things. There's no reason to try sums, adds, or counts, or anything else. Just deal with the problem. All right, so there we go. That's the name, that's the results. Okay, what do I need to do? Well, now, unfortunately, for each one of these results, I've got a whole bunch of things that I now have to go through. I've got a list of course. Oh, okay, well, let's set it up to print it. Instead of printing it in a single line, let's go through each one, because now my results, so for X in results, print X, just so I can see it. What do I get? Well, I get the individual components. Okay, now if you're looking at this going, whoa, there's too much stuff in here. Okay, here's a trick that I use. I stick a break temporarily. How many students will I see? Just the one. So sometimes it's a filtering thing. Just look at the first one. The rest of them, I don't care. I'll deal with it afterwards. Just remove the break. If you can't solve for one, you can't solve for all. Okay, so print the X. Yeah, those are the information. Yeah, I'd be interested in the 80, the 70, but not the -1. And of course, what I need to do is I need to do two things. I need to count them and I need to sum them. Summation. What's the easiest way to sum a bunch of things? We just did this. Yeah, sum. But to do that, you need to stick them into a list. Okay, and if you have them in a list, is it easy to figure out how many items are there? Yeah, it's called length. Oh, okay. So if I can take the 80 to 70, but not the -1, and throw it into a list, I actually have a lot of information. It's going to make my problem really quite simple. All right, so here's what I'm going to do. These are not results, or sorry, these are not X's. What do we call this? Okay, this is a bunch of tuples. So maybe we call this a course. Okay, there's a course. And here's what I'm going to do. Course at 0 is a subject. Okay. I don't think it's important for this, but we at least have it. All right, and by the way, what's course at 1? What would you call that? Yeah, that sounds pretty good. Great, so let's print it out this way. Subject and grade. There you go. Now I split. These are now simple types, so you can work with simple types. You can't work with dictionaries except to apply the dictionary type operations. You can't work with tuples directly, but you can work with primitive types. Because now what I can do is I can start to build up my list of grades. So here's what I'm going to do. Let's have a bunch of grades. Grade's going to be an empty list. And I'm going to ask the question, if the grade is bigger than 0, because we were told to ignore negative things, I'm going to say grades.append grade. There we go. Yeah, that's it. Oh, by the way, when I finish this whole thing, what do I have? I have a name and I have grades. There you go. There's Alice and the 2 grades. And they're in a list. That's really easy to work with now. All right, and if I get rid of this break and look at all of them, there you go. There's everybody. Oh, I think maybe what I'll do is I will not print this anymore. Okay, because I've got it down to simple types that I can work with. All right, to find the max, easy. Or sorry, to find the sum, that's easy. And to find the number of items, that's also easy as length. Okay, so let's now go through and print some extra things. All right, I'm going to print the grades. Okay, I need to find the total grades. Okay, how do I get the total grades? Sum of grades. How do you get the, let's call it the grade count. How do you get that? That's length. Length of grades. All right, let's print this and make sure we've got some sense in this. So this is going to be grade count and total grades, or grade sum if you want. That's the information we're looking for. Okay, 2 grades, 150, 2 grades, 175, 3 grades, 200. These are the numbers we're looking for. All right, now all I have to do is, well, I have to get them back. Okay, we have to send them back to the main program. To figure out what we're going to send it back is, we have to go and, sorry, wrong place. It was over here. All right, and what we need to do is we need to simply make a dictionary with the name of the student, the word subjects followed by the number of subjects, and the total followed by the actual total. This, of course, is inside a dictionary to make it even more challenging. Okay, well, that's fine. But I have all the information. Now it's just a matter of building a result. Oh, how do you build up a result with a bunch of entries? You start with an empty dictionary and you keep adding things. We've done this a bunch of times. It really isn't that much different than things we've done before. Okay, you've seen me do it before. We start off with a result. We start off with an empty dictionary. Okay, down here, we're not interested in printing it. I would be interested in taking the result, going to the name, and simply setting it equal to something. Okay, not like that, because that would create a bunch of sets. That's not what we're looking for. We want to create a dictionary. Okay, well, let's go back and take a look. I'm supposed to have something called subjects. Okay, so the subjects is the grade count. So here we go, subjects is the grade count. And here, I'll put it on the next line because it'll be easier to read. This is actually how I format my dictionaries. And the other item was total. Okay, here we go. So I'll make total. Okay, there's total grades. Take that, stuff it into the result at the key called name, because that's what it's supposed to be based on. And of course, instead of returning none, we'd be returning my result. There you go, we're finished. Okay, all right, yeah, that was fairly involved, wasn't it? Okay, it was involved because unfortunately I had a list inside the dictionary, so I needed really the two lists to process it. Okay, there you go. That's a way how I would solve this, and including the process I would go through. But you notice that the process wasn't much different than what I did a few minutes ago. Even on the really, really simple one, I still did the same thing. Okay, do this calculation, print it. What do I have? If I don't have what I'm hoping to have, I'll figure out what I've done wrong. Okay, and all of these problems that you'll run into from here are going to look very, very similar. I won't solve them. We'll just scan through them. What have I got? Okay, yeah, we're just about finished. Extracting unique ingredients from nested meal plans. Okay, well, just to give you an idea what we've got in here. Hey, take a look. Look at this. I've got a list with dictionaries, and inside one of the fields, I've got a list filled with tuples, and inside the tuples I've got, oh, okay, that one, I'm glad I didn't do that one. I'm glad I picked the first one. All right, but in any case, the way how I would do it, exactly the same. I start by iterating through the list, and I would print these items. And then I would go inside that loop, and I would say, okay, what do I need next? Well, now I need to process the list of meals. And then inside the list of meals, I might need to do something with all these items. I would hope it's going to turn in, I see the word set here. I hope I could just turn this into a set and probably look for things that need to be bought. I suspect that's what this is. Okay, merging and filtering nested inventory structures. Okay, yeah, same idea. You go through. Now this one is definitely sort of in line with the types of things. Yeah, you're going through and you're adding up a bunch of stuff. Okay, we'd have to figure out what all of these things mean. All right, rebuilding a structure from mixed nested types. Ooh. That's probably one of the more challenging ones that I can see here. All right, and again, how would you deal with it? Well, exactly the same way. Start by iterating each of these things. It's a tuple. Yeah, you can probably iterate through each of the tuple items. And for each one of these things, you'd have to figure out what is it that I'm looking at. And then, of course, I'd have to understand what does that mean. Okay, well, I'd have to look. Why do I have only one here instead of two sometimes? Well, all of that should be described up here. But again, I would start by just iterating through what I've got. Ranking candidates. Okay, here we go. Python expected output. So it looks like they're going through trying to figure out which candidate has the biggest number. And I'm not sure what the difference of 7 is. You'd have to read the context to understand what it's doing. But again, the way how I would do it is I would literally start by iterating through the main structure, which is a list, then iterating through each of those things inside a nested loop. Yeah, this is why these nested items occur. Okay, I would spend more time, except you see how long these are going to take. Now, will the questions be quite this complex? The idea was that these were supposed to be more complex than what gets asked on the test. That doesn't mean what I ask on the test is trivial, but these are supposed to be a little bit more complex. But that doesn't mean, because the LLM may generate something that's easier than some of the stuff that I've put. But I usually try not to make them any more difficult than what we've got in here. And I'm usually quite cognizant to say, no, I got to make sure that I keep this under control. Okay? In other words, I don't think you'll see a list of a set of a list of a tuple of a dictionary. It's too many levels. It's too many levels for a 2-hour lab exam. It doesn't mean that you couldn't do it. You'd just be lost because you're dealing with 5 nested loops. Okay? The questions I looked at this morning as the first set of examples out of this thing, it was like, wow, that's really cool. But it asked me to do 3 things in one function. I would have broken that up into 3 functions if I was rating that as an exercise. Okay. All right, so there you go. There's at least some basic stuff. On Wednesday, I will do a question 4 and 5, okay? And maybe we'll come back and we'll generate another one of these from the LLMs because these are tricky things, so we'll work through and we'll just apply the process. Just look at what you've got, see what you've got, understand what you're trying to do, and then eventually, once you have all the information, package it up and send it back. Okay, so coding is not just some magical thing. There's actually a process to it. Okay, everybody's process is a little bit different. What you're learning from me is the process that I use. It works really well for me. You may find that you might want to make some tweaks to it because it may work better in a slightly different format for you. Okay, but hey, this worked for me, and as I say, at least I can justify each of the steps that we're doing. All right, so that's it. I got to stop because